Here we need to find exact answers, and we've got some different inverse trig functions. So first of all, looking at arctan, which is inverse tangent, we need to think about our restricted range. So for arctangent, to cover all values but not repeat, it's going to be the right half of the circle, and we know that it's undefined at the endpoint, so those are open because negative pi halves is a vertical asymptote, and so is pi halves. So positive tangents will be in quadrant 1 and negative will be in quadrant 2, but we've got to follow the interval from negative pi halves to pi halves. So when is the tangent negative 1? We know it's negative 1 at multiples of pi fourths. It uses 1 or negative 1, and so to be negative it would be down here in quadrant 4. That should be in the middle, and that would be at negative pi fourths then. And remember, you can't list a coterminal one and get it correct. It's got to be on our restricted range from negative pi halves to pi halves. Okay, so now I've got an inverse secant, and the restriction for secant follows the same as its reciprocal function of cosine, so it's going to go from 0 to pi, with the exception that right in the middle there is going to be a hole, because we know that secant is the reciprocal of cosine, and at pi halves cosine is 0, so the reciprocal you'd be dividing by 0. So our restricted range is from 0 to pi, leaving out that one value. Okay, so when would the secant be negative 2 over square root 3? Well, it's the reciprocal function for cosine, so the equivalent thing to ask would be, when would the cosine be? Let's take the reciprocal here, negative square root 3 over 2. Wherever the cosine is negative square root 3 over 2, the secant will be the reciprocal of that. Okay, so we're going to be in quadrant 2. And square root 3 over 2 is the bigger value, so it's going to be bigger x, so it's going to be that angle in quadrant 2, and so we know that angle is 5 pi sixths. Okay, let's look at the next one, which is inverse cosecant. Of course, that one's the reciprocal for sine, so we are going to use the same restriction as sine, but we'll have from negative pi halves to pi halves here, we will have a hole in the middle, because right there at 0 the sine is 0, and therefore their reciprocal function make us divide by 0 wouldn't exist. Alright, so if we're asking when is the cosecant negative square root 2, we could ask an equivalent, when is the inverse sine the reciprocal of that? And so when is the inverse sine negative 1 over square root of 2? Now that might not be recognizable as a unit circle value just because it's not rationalized. If we rationalize the denominator, it's negative square root 2 over 2. We could times top and bottom by square root 2, and the bottom would become 2 and the top would have the square root on it. So it is a unit circle value, and that unit circle value, when is it square root 2 over 2, that's at pi fourths. I'm looking, my circle's really squashy there at the bottom. I'm going to try and make that a little bit better. Okay, so now when is the y value negative square root 2 over 2, and we know that is at negative pi over 4.